Meet DepGraph, an open-source dependency risk graph designed to help developers understand how vulnerabilities propagate through software dependencies. Instead of simply telling us that a package is vulnerable, DepGraph helps answer a more important question. How does that vulnerability actually reach our project? To solve this, we model projects, packages, versions, dependencies, and vulnerabilities as connected entities in a graph. Our seed dataset contains both normal package versions and versions associated with clearly labeled demo advisories. These CVE-demo records are synthetic data, not real-world vulnerability intelligence. They are included to demonstrate vulnerability impact and dependency traversal. When a project's package and version match a demo advisory, DepGraph traces that relationship through the graph and shows the resulting impact path. When a project is imported, the analyzer evaluates it against the vulnerability data available in the graph. So if an imported project's package and version match one of these demo records, the application can demonstrate the corresponding impact path. This is the DepGraph dashboard, providing a high-level overview of the dependency ecosystem. Here we can see projects, packages, dependency relationships, and vulnerability information. The application is backed by CognoDB, where these entities and their relationships are stored as graph data. The project also includes a reproducible seed dataset for the demonstration. Let's take ShopStack as our example project. A software project doesn't only depend on the packages it directly installs. Those packages can introduce their own dependencies, creating deeper transitive dependency chains. DepGraph models these relationships along with specific package versions, which is important when a vulnerability affects one version, but another version may already be patched. Now let's explore those relationships directly. The Dependency Explorer lets us navigate these relationships visually. Starting from the project, we can follow its direct dependencies into packages and specific versions, and then continue through multiple levels of transitive dependencies. Rather than looking at a flat dependency list, we're exploring the actual relationships connecting these entities. This is where graph traversal becomes useful. Now we can focus on a package with a security advisory. But identifying a vulnerable package is only the first step. We also need to understand which version is affected, whether the dependency is direct or transitive, and how that package is connected to our project. That's where the vulnerability impact analysis becomes important. The vulnerability impact analyzer determines how the vulnerability connects back to the selected project. Instead of simply displaying vulnerability information, it analyzes the dependency relationships and identifies the paths connecting the project to the affected package and version. This turns vulnerability information into project-level impact analysis. Here we can see the complete multi-hop dependency path. The vulnerable package doesn't necessarily have to be installed directly by the project. It can be introduced through several layers of transitive dependencies. DepGraph traces these relationships hop by hop, showing exactly how the project reaches the affected package. This is where a graph database becomes particularly useful because the number of dependency hops isn't fixed. We can also traverse the graph in the opposite direction. Starting from Lodash, we can ask who depends on this package. The graph shows 5 dependent projects with 0 direct dependents and 5 transitive dependents. At the first level, we can see packages such as Recharts, Package A, Package C, and Package X, and we can continue another level upward to their own parents. The affected projects range from 1 hop to 4 hop dependency paths, giving us a clear view of the potential blast radius. DepGraph is open source. Can also import public GitHub Node.js projects for analysis. Thank you for watching.